I wanted to do one more rate, time, and distance problem, and this is a little out of sequence with the other videos because my videos tend to match the topics in my book. But this problem is really out of the ordinary, and it's kind of a special problem to me. There's one like it in your textbook, and that's where I got the idea. It's a brilliant problem. I don't know if your textbook author came up with that on his own, but whoever did, it's a well-conceived problem. So let's read through it. A car averages 65 miles per hour going from Hillsboro to St. Louis. It then averages 55 miles per hour going from St. Louis to Wichita. That'd be Wichita, Kansas. St. Louis is halfway between Hillsboro and Wichita. What was the average speed? All right, now I have actually driven this. My daughter and I took a trip, and we went from Hillsboro to St. Louis, spent the night, then St. Louis to Wichita, spent the night there. I have relatives out just outside of Wichita, so we wanted to see that part of the country. But that's beside the point. I looked on the map, and sure enough, St. Louis is about midway in between. So I used this, and there is an obvious answer here, isn't there? What is the obvious answer? Has to be 60 miles per hour. What's amazing is that that's wrong. 60 miles per hour is not the average speed. I know half the trip you go 65, another half you go 55. Why wouldn't that average out to 60 miles per hour? Well, I'll show you why in a minute. A real easy reason to see why that has to be wrong. And but the other remarkable aspect about this problem is that it really doesn't matter. You know, the problem doesn't tell you how far it is. You know, how can you tell how far you're going? We have no time given to us, and the only distance is that it's the same distance. St. Louis is in between these two other cities. And so what's kind of interesting is that it doesn't matter how far apart all these cities are. They could be 3 feet apart and you would have the same answer. So that's the other, I think, interesting aspect of this problem. So I've kind of given away what's going to unfold before us, but I want you to see why. And this is kind of a tough problem, I think, for an algebra class, so I'm going to walk you through it. But first of all, let's dispense with it can't be 60 miles per hour. All right, so and I'll draw my little sketch here. Here's Hillsboro, St. Louis, and Wichita. And these distances are the same. Now in the problem, let's see, we want 65 miles per hour from Hillsboro to St. Louis and 55 miles per hour St. Louis to Wichita. Well, there are a lot of places in math where you can see things more clearly if you look at something really extreme. Look at an extreme case. So what if I change these numbers? I want to show you that the average speed for the whole trip cannot be simply the average of these two numbers. Suppose that we went 999 miles per hour from Hillsboro to St. Louis. Okay, I know that's ridiculous, but like I said, you can understand some things in math by looking at extremes. Suppose we went 999 miles per hour from St. Louis, Hillsboro to St. Louis, and then we decided to go 1 mile per hour from St. Louis to Wichita. All right, now how long is it going to take you to go from Hillsboro to St. Louis at 1,000 miles per hour? Not very long, you know, less than an hour. It's going to be extremely fast. So you're going to get here in no time, less than an hour, we'll say. How long would it take to go from St. Louis to Wichita? And that's, you know, a couple of hundred miles, maybe 400 or so miles. It would take you many, many hours. It actually would take days. It would take a number of days or weeks to walk from St. Louis to Wichita. So if I went here in under an hour, and I went here in a couple of weeks at 1 mile per hour, it might even be a month or two, what's the average speed? The average speed would be closer to 2 miles per hour, wouldn't it? It would not be the average of these numbers, and is 500 miles per hour, right? Well, if you drove, or could drive, or could travel 500 miles an hour from Hillsboro to Wichita, it would only take an hour or two, well, maybe 2 or 3 hours. It wouldn't take very long at all. It would take a lot less time going at this average and these two numbers, a lot less time than it would take going 1 mile per hour half the distance, because that would take, this trip up here would take, a month or two. So I hope that extreme, you can see why it would be faulty thinking to say that I can just average these speeds together. Doesn't work. Doesn't work. So back to the drawing board. Let's see if we can set this up now. I have to make a lot of room here, so I'm going to erase the whole board, and so I'm assuming you've got all this in your head, and then we'll work from there. Like all these problems, you're going to get 2 trips in our textbook. You can cook up other kinds of problems where there's more than 2 trips. They become more and more complicated, but here are 2 trips, obviously, are going from Hillsboro to St. Louis and then St. Louis to Wichita. So the first trip, Hillsboro to St. Louis. And how are we going to do that? Well, the distance for that trip would be the speed, which was 65 miles per hour, times the time, but we don't know how much time it took. So, and not only that, it took a different amount of time for the second half of the trip. Because if they're the same distances, but they're driving a different speed, then the first part of the trip is going to take less time than the second part of the trip, won't it? So we have 2 different time values. So what I'm going to do is call it T1 hours for the first trip. T1 hours. Okay, so that's what T1 is for time first trip. And then, so the distance is going to be, hours cancels, for that trip is 65 T1 miles. Alright, so let's do a similar calculation from St. Louis to Wichita. And this distance would be 55 miles per hour times what? Well, again, it's a different time. It took longer because they're going slower. So let's call that T2 hours for time 2. Time for second trip. Alright, so hours cancels, and that distance equals to 55 T2 miles. Now, what other information do we know about this problem? We know that the distances are equal, because St. Louis was exactly in between in this problem. So, I'll just write that down as an observation. The distances are equal. Which means that 65 T1 equals to 55 T2, both in miles. Alright, now, how can I solve that? I have one equation with 2 unknowns. But what are we solving for? The question asks for the average speed for the entire trip. And so I'm going to write that out. What is the average speed for the whole trip? I need to be able to calculate it. So we need to make room. But watch how this comes together here. Okay, the average speed for the entire trip, for a whole trip, is what? Okay, well, the average speed would be the distance covered divided by the time. So how much distance was covered? All right. Well, in the first part of the trip, they covered 65 T1 miles. 65 T1 miles. Second part of the trip, they covered 55 T2 miles. And then, average speed is miles per hour in this case. So hours, how long did it take for the entire trip? And that would be T1 plus T2 hours. So what I'm trying to solve for is exactly this. I want to know the average speed of the entire trip. And I need to add up the total miles traveled and divide by the total time it took. So we have calculations for distance, and these are equal, and that's going to play a big role here in a minute. But these are equal, and but the times are not equal. T1 and T2 have to be different. All right, so now what? Well, in order to work this, I thought, well, look, I can substitute something here. I could 55 T2, I can replace up here. So here's my strategy. I want to replace the T2s with T1s. So if I replace 55 T2 with 65 T1, then this becomes 65 T1 plus 65 T1. Down below, I also want to replace T2 down below, but and T2 would be what? If I divide both sides by 55, then I have an expression for T2. And so this would be this T1 plus this T2, which is 65 T1 over 55. So it's 65 T1 over 55. And you think, well, gosh, it's going worse. Well, no, actually it's getting much better. Because, look what I got here. I can factor out a T1 out of the numerator and a T1 out of the denominator. When I factor the T1s out, so I have T1 parentheses 65 plus 65 over T1 times 1 plus 65 over 55. Look what happens. The T cancels, the time cancels, which is remarkable because this is going to give us a numerical answer. And in fact, this numerical answer, it didn't matter how far it was between cities, as long as they were the same distance. And ultimately it didn't matter how much time it took. What mattered was the speed. And so if you work this problem for, walking from here to, the lamppost, and from the lamppost to the end of the street, if those are the same distances, if you were traveling 65 miles per hour from one to the other and then 55 for the other, it doesn't matter what the distances are. We're going to still get the same speed because all the variables cancel off here, and I get a numerical answer. All right, so we'll finish it up, and it's going to be a little bit messy. Let's see. On top, I've got 130. And down below, I've got, let's see, this would be 55 over 55 plus 65 over 55. That would be 130 over 120 over 55. So we can, you can punch this in a calculator at any point, but if we invert and multiply, it would be 130 times 55 over 120, and we can divide a 10 off. So 13 times 55 is 715 over 12, and that will not reduce, but it is, let's calculate. 715 divided by 12 is 59.58. 59.58. So write the answer here. The average speed it's approximately, but it's about 59.58 miles per hour. There we go. Now, that was very close to 60 miles per hour, wasn't it? So the 60 was a good estimate for this problem. But the point was is that it wasn't exact. It's not as simple as taking a simple average. And it is different. So now if there was a greater disparity between the two speeds, then I think this would be further off from 60 miles per hour. And so anyway, there's the problem, and I hope you got a lot out of it. I think it's a very nice problem of this type.